Hi guys, welcome to Nunley Math. I'm Aaron Nunley. Thank you for joining me here today for the first lesson in our new unit on applications of algebra. You will know if you've been following along with my class that we just wrapped up a unit on algebraic equations and expressions, and we spent a lot of time talking about the patterns or the rules in nature that govern how we can manipulate and rearrange algebraic equations and expressions. And we talked about how we can use that to make expressions reveal certain patterns or make them simpler to understand. What we did not spend much time doing in that unit is talking about the why we bothered to do that. That's what this unit is for. So we're going to be using equations to model real situations today, and then we're going to talk about maybe some more advanced applications over the course of the next several videos. I'm actually going to split this lesson into two videos, so make sure you check out the second half of this video if you would. I think you're going to find it useful and interesting. So let's go ahead and dive right in. I'm actually going to start off today with a little magic trick, a numerology magic trick, meaning we're going to do a magic trick that's based on numbers and number patterns. I am not going to allow the same pauses that I would allow in my classroom because there's nothing worse than sitting here listening to me not talk on the video. So if you need a second to do some calculations as we're going through, I'm going to recommend that you pause the video, do your calculations, write down any work you need to, and then restart the video for so that you can join in with the rest of it. So here we go. I'm going to do this fairly quickly, trusting you to pause as you need to. I want you to think of a 1 or 2 digit number and write it down. And once you've done that, I would like for you to double your number. And then once you've doubled your number, I'd like you to add 8 to your result. And then divide that new result by 2. We're going to refer to this number that you have now as your new number. I'd like you to subtract the original number you picked and wrote down from your new number. And then I would like for you to assign your result a letter based on the letter of the alphabet it corresponds to. So if you got the final answer of 1, I'd like you to assign the letter A. If you got a final answer of 2, I'd like you to pick the letter B. 3 is C, and so on, all the way through 26. If you got a number higher than 26, which is Z, I recommend that you recalculate because something has not gone right. And then I'd like you to think of a country that starts with that letter and write that down. And then lastly, I'd like you to think of an animal whose name starts with the second letter in the country that you chose. Wait a second, something that doesn't seem to make any sense to me. Because it's impossible. They don't have elephants in Denmark. They don't have elephants in Denmark. Did I get you on that one? It's kind of, I want to walk you through this. It is possible that you may not have gotten elephants in Denmark, and I want to talk about that. But before we do that, what I want to do is I want to jump through this, this magic trick mathematically. And I'm going to use some of the skills we learned in our last unit on algebraic equations and expressions to kind of help you understand how this trick is done. See, we think of a 1 or 2 digit number, but you did not tell that digit or number to me. So we're going to call that X. X always represents something we don't know or something that can change. Since I don't know your number, I'm going to call it X. Your first instruction was to double that number. Double, you'll remember, means multiply by 2. So this is 2 times X or 2X. And then I asked you to add 8 to your result. So I multiply first using order of operations, then I add my 8. I then ask you to divide your result by 2. This is going to be your new number. And then I ask you to subtract your original number from that. Notice, doubled, added 8. I put parentheses out around it because I have to do all of that before I divide by 2. And then we said subtract the X from that. Now, I want to look at this algebraic expression for just a couple minutes. And I want to make a few changes to it based on what we learned in our previous chapter. For example, we have this divided by 2 here. We learned that dividing by 2 is the same as multiplying by 1/2. So I'm going to use my distributive property, and I'm going to multiply everything inside these parentheses by 1/2. And then, of course, we have an X of 4, and this would be a plus negative X. Commutative and associative property allows me to rearrange and regroup this. X and negative x make 0x or 0, leaving me with just the number 4. You see, no matter what number you started with, using algebra you can see that I have forced the result to be a 4. And then once I know that your number is 4, I also know that you're going to have the letter D as the first letter in the name of your country. Most people are going to pick Denmark. There are other countries that start with D, hence the reason that I may not have gotten all of you with my little trick. There's Djibouti, Dominica, Dominican Republic, and I'm sure you might be able to think of some other countries. If you picked Denmark, which the majority of people tend to do, you'll notice that the second letter in that word is an E, and then most people jump to elephant. It is possible that you might have said something like emu or something else along those lines, but the majority of people are going to think of elephant, wow, the first time. That's how this trick is done, and it's honestly how a lot of number sense tricks are done by magicians. This idea that they have examined the pattern and they've created a problem in such a way that they force you to end up with what they want you to have. And once they know what they want you to have, then they can use a series of other tricks to end up with a word result or something along those lines. You see, this is just a little bit of mathematical manipulation, but it does demonstrate how using variables to represent things we don't know can be used to solve some problems. Here's another little trick for you. I want you to pick a set of 4 numbers that form a square on the calendar at the left. Let me give you an example of that. Something like 8, 9, 15, 16. Notice that I have a square, it's too wide, and it is too tall. Please don't do something weird like pick something with an empty spot. That will make the trick not work. The idea of this trick is that you should be able to find the sum, and then if you give me the sum, I should be able to predict the set of numbers that you use very quickly and easily. So here's what I want to do. I want to think of this in a particular way. Notice this blue box right here has the number 8 in it, which I would not know. I'm going to call that first number x. The first unknown is always your first variable. I tend to use x's and y's a lot, but really you could use any letter you like. When I go to look at this number that's in the red box, notice that it is a 9. Now I could call this second number y, and that would work out. However, just know that every time you change and add an extra variable to your algebraic equation, you're making it into a much, much harder problem. So ideally, I want to keep this in terms of x as well. So although I may not know what this number is, it is going to be 1 larger than the 8 was. So I can express this number as x plus 1. If you had picked 12, 13, 19, 20, and 12 had been your first number, 13 would have been x plus 1. If you'd done 18, 19, 25, 26, 18 plus 1 would give you 19. The second number is always going to be 1 bigger. Can you give me an expression using x that would give you the 15? If x is 8, 15 is 7 larger. And in fact, no matter which number you pick, the number beneath it is always going to be 7 larger because it's 1 week later. And probably at this point you can predict that the 16 would be represented by an x plus 8. I have a number. I'm always using a number that's 1 larger than my number, a number that's 7 larger than my number, and a number that's 8 larger than my number. So here's what I'm going to do. The instructions in the problem were to find the sum. So I'm going to take x, add the x plus 1 to it. So there's my first number, there's my second number. I'm going to add the x plus 7. I'm going to add the x plus 8. And the sum, if I were to add this up, is a 48. This is an algebraic equation in one variable, like the ones we did in our previous unit. Solving this should be fairly simple at this point. I have 1, 2, 3, 4 x's. I have 8 plus 7 is 15 plus 1 is 16. This is 4 x's. And a 16 make a 48. And then I would use the property of equality to get rid of the 16s. And then I would use the property of equality to divide away the 4. Notice this tells me my first number was an 8. Once I know the first number is an 8, I know the one that's just to the right is 9, just below is 15, and this one would be 16. Once you know the first one, all you have to do is add 1, add 7, and add 8 to get the others. Now, it's not nearly as impressive when I explain it to you as it is when I'm in class and I just ask you to do the problem and I jump right in and tell you what your 4 numbers are. Because this looks like it takes an awfully long time, and in reality this did take a long time, but it does reveal a pattern for us that will make it faster in the future. For example, I know no matter what my number is, if I multiply it by 4 and add 16, I'm going to get the sum that you tell me. Or the other way around is I could say, if I know the sum, all I have to do is subtract 16 and divide by 4, and it gives me the number. Let's try this. My sum is a 60. Can you predict the 4 numbers that would give me a 60? Well, you could take the equation we just generated, subtract the 16, divide by 4, and know that the first number is this 11. That means the next number is 12, the number underneath that is 18, and the number after that is 19. And you found the 4 numbers. That's actually the longer way to do it. There is a faster way. You could say my sum is 104, and instead of setting up the equation and then working using the property of equality, you can just realize that we take the original number, subtract 16, and divide by 4 to get the number in the top left. So if I were to do that with 104, 104 minus 16 is going to be 88. 88 divided by 4 is 22. I can very quickly tell you that the numbers are 22, 23, 29, and 30. That's pretty cool. It's way more impressive for your friends if you let them pick the month on the calendar, because the month doesn't really matter, and then you have them give you the sum and you go back and very quickly calculate what the numbers are. Obviously, of course, you do need to have a little bit of mental math talent. You need to be able to subtract this and divide this fairly quickly in order for it to be impressive. There are other ways that you could do this, this same pattern. You could walk through here and say, take your original number, divide it by 4, and then subtract 16 divided by 4 is 4. So I could take this right here and say, oh, this is 26 when I divide by 4, and then subtract the 4 and get 22. But there again, that mental math manipulation really isn't the focus. The idea here is just to give you a cool trick to work with. Here's a second one. Same idea. I've gone through, I picked a calendar. This one's April 2021. I've blocked out a set of 8 numbers so they surround the number 13. I want to be able to quickly calculate the sum of the numbers. Now I could sit here and go 5 plus 6 plus 7 plus 12 plus 14 plus 19 plus 20 plus 21 and tell that to you, but that's going to take a long time and it really isn't that impressive. Also, it isn't reversible where if somebody gives you the sum, you can figure out the center number either. So let's see if we can figure out what the pattern here is. I don't know what each of those numbers are, so what I'm going to do is I'm just going to call my 13 x. 13 is x. If 13 is x, we can use what we learned in the last slide to say that 14 would be what? How about x plus 1? No matter what number's in the middle, the one immediately to the right is always going to be one bigger. So if 16 was in the middle, 16 plus 1 is 17. If 23 is in the middle, 23 plus 1 is 24, and so on. Can you predict what the 19 is? How does x plus 6 sound? It's always going to be 6 larger than the middle. How about the 20? X plus 7. And the 21 would be x plus 8, because 21 is 8 bigger than 13. What about the 12? Isn't it 1 smaller than 13? And the 7, isn't it 6 smaller than the 13? That means the 6 is 7 smaller than 13, and the 5 is 8 smaller than the 13. How can we use this? Well, we want to know the sum of these numbers. So I'm going to take the x plus 1, and I'm going to add the x minus 1. Then I'm going to take the x plus 6 and the x minus 6, the x plus 7 and the x minus 7, the x plus 8 and the x minus 8, and altogether those have to give me the sum. They have to give me the sum, whatever that might be. Now this looks like a really long, complicated algebraic expression, but check this out. X plus 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 x. How many x's is that? Well, it's 8 of them, isn't it? And take a look. 1 and negative 1 make a 0. 6 and negative 6 make a 0. 7 and negative 7 make a 0. 8 and negative 8 make a 0. This is going to be 8x plus 0, and the identity property says adding 0 doesn't change anything. If I want to know what the sum of these 8 numbers are, all I have to do is take that middle number and multiply it by 8. Or in this case, I'm going to take 8 times 13. Well, 8 times 10 is 80. 8 times 11 is 88. 8 times 12 is 96. 8 times 13 is 104. Pretty cool, right? Now, again, we did it a really long way, and usually you're going to find that developing the pattern or the trick is usually the hard part. But once we know that pattern, check this out. I can do the same thing, and I can say, what's the sum of the numbers that surround a 22? Well, I already know that the answer is going to be 8 times 22, and all I have to do is do a little mental math to figure out that's 176. I would do 8 times 2 is 160, 8 times 20 is 160, 8 times 2 is 16, and I would add those together. You could do that lots and lots of different ways. Or how about this? What if somebody told you that the sum of the numbers surrounding their number is 96? Could you figure out what that middle number is? Hopefully you've paused the video and had a chance to think about that. All you have to ask yourself is 8 times what makes the 96? Well, that would be a 12. You get the number over here. I think that's pretty cool. A lot of different cool little tricks you can do with that, and that's really all we're doing when we talk about modeling things algebraically, is we're saying what kind of patterns can we discover in the numbers that might be useful for helping us solve particular problems. Here's one that's more like what might appear on a homework or a test in my class. If I said I have a set of consecutive numbers, I'd be talking about numbers like 16, 17, and 18, where you have 3 numbers in a row. Or how about 35, 36, and 37? Something like that. If I had told you I have 3 consecutive integers and their sum is 144. We can use the same principles we used in the magic trick and on the calendar in order to figure out what those numbers must be. So how about this? Do you know what the first number in your sequence would be? Since we don't know it, we're going to call that x. What about the second number? If you look at the pattern, can you see how the second number always compares to the first number? Well, it's always 1 larger, which means the third number compares by being 2 larger than the original. Notice I've defined my variable so that anybody looking at my work will understand what it is I'm trying to accomplish, and then I'm going to do exactly what it says here. I'm going to find the sum of these 3 numbers that I don't know. I have an original plus the second number plus the third number, and it has to equal 144. I'm going to use the skills we learned in our last unit and simplify this to 3x's and a 3 is 144. A little property of equality, and then divide both sides by 3. I get that the first number is a 47. Once I know the first number, the second number has to be 1 bigger, and the third number has to be 2 larger. The consecutive numbers that add up to make 144 would be 47, 48, and 49. Again, it's the same thing we learned in the magic trick, we learned in the calendar problem. We're just applying it in a way that you might see in a math class. Here's another one. 3 consecutive integers have a sum of 219. What are the numbers? I'd recommend pausing the video, seeing if you can work this one out on your own, and then restarting the video to see if it matches what I have. Certainly you can skim past my instructions and my explanation if you got it quite easily. I always make sure I define my variables. In my class, this is a requirement. If you did not tell me what x plus 1, and x plus 2 stood for, I would not give you credit on this question, even if you got the final answer right. Very important you tell people what your variables stand for. We're finding their sum is 219, and there again, we're just going to use some algebraic properties to figure out that we're talking about a 72. Once I know the first number is a 72, the second number has to be 1 bigger than that, and the third number has to be 2 larger than the original number. Here's another type of pattern that uses a very similar strategy in order to find a solution. This is about consecutive even and odd problems. If I talk about consecutive even numbers, I'm talking about something like 46, 48, and 50, or 8, 10, and 12, where you're talking about three even numbers that appear in a row. So I might ask you, three consecutive even numbers have a sum of 84. What are the numbers? Could you do this one on your own? I'd recommend you pause and try. If you've already done that, go ahead and pay attention here to what I'm doing. I'm going to say the first number is x, as always, but notice the second number is now 2 larger than the original number. And the third number is 4 larger than the original number. Doesn't matter what the original number is, the second number is 2 bigger, the third number is 4 bigger. Can you write the equation now? Well, the problem says find their sum, so I add those together. It has to equal 84. Again, that was the hard part. The rest of this is just a little bit of algebra, making sure we always show our work. We come up with the fact that we have a 26 for our first number. If the first number is a 26, the second number must be 2 larger than that, which is 28, and the third number must be 4 larger than the 26, which is a 30. Can you do it with consecutive odds? Again, I'm going to recommend that you pause the video, try this on your own. Notice I'm doing 3 odds in a row, 3 odds in a row. The first one's always x. See if you can figure out the pattern on your own, and then pause the video, restart the video when you're ready. I'm going to keep right on going. Notice that with consecutive odds, the second and third number are also 2 larger and 4 larger. This is the same pattern as we have with consecutive even numbers. We start with an odd and add 2 every time. Over here we were starting with an even and adding 2 every time. The problem says our sum is 219, so we just add those together. And then we've got a little bit of algebra to work our way through it. Notice that your first number must be a 71. Your numbers are 71, 73, and 75. I think this is a good spot for us to take a break. I am going to cut off the video here and then do part B as a separate video. Please make sure you check us out in that video as well. Thank you as always for joining us. I do wish you all the very, very best. Make sure you give us a big old thumbs up. If you have not subscribed to our channel yet, make sure you subscribe so you can catch all the new things coming here from Nunley Math. Appreciate you guys very much. Take care of yourselves, all right? Bye-bye.